Hi everyone, I wanted to finish our lesson 2.5 lesson that we didn't get to last week, the last three questions of those. But before I do that, I also wanted to take up one of our homework questions, just in case there were questions with it. So the questions we're doing today, I really love. They're super interesting examples of systems that are a bit more complicated than your regular system of two linear equations. So let's have a look at this. I can see that I have three equations, and I also can see that I have three variables. So I've given a hint here to substitute z from the first equation into both of the others, and I'm just going to go and do it so that you can see the reason for that. So I know equation 1 is z equals x plus y, and what I'm going to do first is sub 1 into 2, being mindful that I have to write brackets around it, and I'm going to distribute that negative, and I am going to simplify. And what you'll notice is the y's actually cancel out, and I get a solution here. I get a solution for x, which is really nice. We're going to try this again. So what you'll notice is once I sub z, the equation for z, once I substitute out z and substitute in the expression for z, I can see that z actually disappears, which is the whole idea of making the substitution. So what happens when I sub 1 into 3? Okay, so now I have another equation. I have x plus y equals 6, and this is basically equation 3 just rewritten without z. I've substituted z out. But now something really nice happens. I already know what x is, so I can back substitute that into this equation. And remember how I said, as long as we're doing legal algebra, whatever we do should be correct. Okay, so I have legally subbed in x equals 1, and now I can see that y equals 5. Well, how do I solve for z? Okay, well, I'm going to sub x equals 1 and y equals 5 into any of the equations 1 or 2 or 3. It doesn't matter. So I'm just going to sub it into 1 because 1 is actually the simplest. And then I'm going to write my solution statement. Always in alphabetical order. X, Y, Z. Okay, something nice we can do, we can always go back and check this. So that's what I'm going to do. If I know that my solution is 1, 5, 6, let's go back up here and let's check 1, 5, 6. Okay, so I have z equals x plus y, 6 equals 1 plus 5. Yes, that's right. 2x plus y minus z equals 1. Well, I have 2 times 1 plus 5 minus 6, which equals 2 plus 5 minus 6, which is 7 minus 6, which is 1. So that one's right too. X plus y plus z equals 12. 1 plus 5 plus 6 equals 12. It's right. All right, so we can use substitution there just to replace z with x and y, and then we can proceed as we normally would. So now for my favorite kinds of systems, non-linear systems. Let's have a look at these. So I apologize in advance. I'd like you guys to write really small here because I actually don't think I left you enough or very much room. So I'm just warning you now. Please be mindful of spacing. So what's better here, substitution or elimination? Okay, so a parabola and a line, we know that, or we saw earlier, that sometimes we have systems where we're not just dealing with two lines, we're dealing with different geometric figures with a line. We can still solve these. Okay, so what I'm going to suggest here is we're actually going to use substitution for this one. So I see y here and I see y here, and I think if I take equation 2 and rearrange it, and then I sub 2 into 1, we should be able to solve. I could do it the other way as well, but I just think this might be a little bit simpler. And what I want you guys to think about here is doing quote unquote what I was saying before, legal algebraic moves. So I'm going to expand here, and the reason I know I need to expand is because I have terms that look like they can be combined. So I'm going to use my perfect square trinomial pattern here to expand. So I know that's minus 10x plus 25 minus 10. And then what I'm going to do is bring the negative 2x over. Okay, and in the next line, I am going to simplify. All right, now you might be wondering why I chose to bring the 2x over to the right-hand side. There's a very important reason for that. I always want one side to be 0. And I'm going to draw this sun figure here because I think that helps guys remember that if one side of an equation is 0, I can actually solve it in a way. I can actually solve it easily by inspection. What do I mean by solving it? Well, remember, solve means to find the x values that make the left-hand side equal the right-hand side. So if the left-hand side is 0, that actually makes it a bit easier. All right, now what we're going to do, I've set something up for you very nicely here, and hopefully your intuition is that we are going to factor this thing. So let's do that. I know I need two numbers that multiply to 15 that add to negative 8. All right. So once I've factored this, I can really easily see the x values, okay, that make the right-hand side equal to 0. So for example, if I have x equals 3, right, I have 3 minus 3, 3 minus 5, which equals 0 times negative 2, which is 0, right? I can also see that if, say, x is 5, okay, I'm going to get 5 minus 3, 5 minus 5 equals 2 times 0 equals 0. So what's really nice here is when I have this sunshine 0 on one side, I can actually solve for x really quickly. I know that the x values that solve this are x equals 3 and x equals 5. So what that means is I actually have two different x values that solve this system, which means that I actually have two different points that solve this system, okay, which makes sense because I have a parabola intersecting with a line. How do I find the associated y values? Well, what I'm going to do is I'm going to sub x equals 3 into equation 2. I get 2 times 3 plus y equals 0, and y equals negative 6. Then I'm going to sub x equals 5 into 2. I'm going to get 2 times 5 plus y equals 0. That means y equals negative 10. So in that way, I've just found the two solutions to the system. I'm going to write it here. The solutions are 3, negative 6, and 5, negative 10. All right, and what I'm going to do actually, whoopsie, is I am going to show you what this looks like. All right, so all right, and what you will notice is that when we graph the two functions, we sure do have a point at 5, -10 and 3, -6. All right, so I've added that last one in there so we have a nice visual of it. So you guys will not be expected to know how to graph this, but I think you should be able to see it by substitution. Okay, let's try the next one. And again, let's try to conserve space. Okay, and I think, okay, probably the obvious substitution is isolating y in equation number 2. Okay, and then subbing it back into 1. Now remember, by the way, common mistake, x minus y equals 2. Some guys think they can just slap on a power of 2 to any of these. Okay, that is not a legal algebraic move. Okay, so please avoid this common mistake. Okay, you cannot do that. But what you can do is isolate y in the second equation and sub it into the first equation. All right, now good thing we know our perfect square trinomials because that saves us probably one step in simplifying. All right, so now for that sunshine moment, we are going to bring the 25 over and we're going to simplify this quadratic. So I get 2x squared minus 2x minus 4x is minus 6x. And then I have 1 plus 4, which is 5, subtract 25. Okay, and now I can actually divide by 2, which makes this nice. All right, now you know what comes next. Your favorite thing to do, factor. All right, so in order to solve this system, what we're going to do is factor that quadratic, and then I'm going to find the x values that make this quadratic, make this factored side 0. And I can do this by inspection. Okay, I can just see that these two values, x equals 5 and x equals -2, create a 0 on the left-hand side. Okay, so we're going to sub x equals 5 into, and I think 2 again is going to be the easier one. So that's 5 minus y equals 2. So y equals 3. All right, so let's look at the second point. We're going to sub x equals -2 into 2. All right, so I've got y equals -4. So again, I would like to go to Desmos, and we can have a look at this. All right, so if we take a look at this, we can indeed see that -2, -4, and 5, 3 are points on this line. So I'll take a screenshot and put that into our note. All right, last one, a parabola and a circle. Now this one is a tad different, okay? I don't think I would put in a substitution here. And hopefully you guys can see that because these two terms are the same, I think if I just take equation 2 and multiply it by -1, I can use elimination. So I'm going to copy and paste the first equation, and then I'm going to multiply the second equation by -1. So all the terms there will change sign, and I can see that the x minus 1 squared terms actually cancel. So I end up getting y squared plus y equals 0. Now what's interesting about this one, it's different than the other two in that I was solving for x in 3 and 4, but here I have an equation involving y values. So we can also see that we have already been graciously given a sunshine on one side, so that really helps us. So what we're going to do is we are going to take the left-hand side and we're going to factor it. And in this case, there's just a GCF. And in this case, I actually have y values that I can see will cause the left-hand side to be 0. So don't forget about this one right here. Okay, if y is 0, that will cause the whole left-hand side to be 0. So don't miss that solution. Okay, so if I know that y equals 0, okay, I'm going to sub that. It actually doesn't matter if I sub it into, into 1 or 2, I'm going to get the exact same thing. So we're going to sub it into 1, which means I get x minus 1 squared equals 1. Okay, what do I do with this? Well, I need to expand it because I can see that I can probably collect terms. All right, and then when I bring that 1 over, I actually get 0. So I'm going to do that same thing. I have a sunshine here. Well, I made it. I put it there by bringing the 1 over because I know that actually, okay, I can factor this. So when y equals 0, that means x equals 0 or x equals 2. So I got like a 2-for-1 deal here. What that means is one of my solutions is 0, 0. Okay, 0, 0. And the other solution is 2, 0. Okay, so I get x equals 2 and y equals 0. So I actually got two solutions from that one y value. All right, last one here. So what happens when I sub y equals -1 into 1? All right, so I get x squared, x minus 1 squared plus -1 squared equals 1. X squared minus 2x plus 1 equals 1. All right, so these ones start canceling out. Actually, what I should have done, this is probably easier. X minus 1 squared plus 1 equals 1, right? And then the ones cancel out, so I see x minus 1 squared equals 0. And by inspection, and again with the sunshine on this side, what value of x makes the left-hand side equal to 0? Well, it's pretty clear that it's x equals 1, because 1 minus 1 squared is 0. So I have another solution. It's 1, -1. Okay, so I got the x value from here. Okay, so my x values. And then my associated y values. Come from the y's that I've subbed in. Okay? All right, let's go to Desmos and have a look at this.